Again, we're multiplying and dividing, solving multiplication and division equations today. Again, topic 16. So you're going to put topic 16, today's date, and the heading. Solving multiplication and division equations. Yesterday we went over the notes, which was actually the meat of solving. You know that you solve by doing the inverse operation or the opposite operation of whatever's been done to your variables. So knowing that and practicing that yesterday and being able to check, doing all of that same thing, all of that, those same strategies today, we're just starting out today with examples. Because it's doing the exact same thing yesterday, except yesterday was adding and subtracting, today is multiplying and dividing. So if I had x over 7 is equal to 20. We have an equal sign, that means we have an equation. That means both sides need to stay balanced. That means what I do to one side, I do to the other. So basically what I have to ask myself at the beginning, and ask myself at the beginning always, is what has been done to the variable. What have I done to x? It has been divided by 7. What's the opposite of division? We're going to multiply both sides by 7. Now remember, this is the center of your balance. When I do that, these are going to cancel out. Because this is really multiplying fractions, and I would change that to a fraction. And if I multiply across the top, that's 7x, and if I multiply across the bottom, that's 7. And if I have 7x divided by 7, 7 divided by 7 is 1. And it brings it down to just 1x. So you won't have to do that. All you will have to do is just cross them out, because you know it's the inverse operation and it's undoing what was done. I just put the 1 there and explain that to you so you would understand why they cancel out, because it reduces down to 1, but they're not going to write the 1 there. When you see just 1x, you're assuming it's 1x, that the coefficient is 1. 7 times 2 is 14. Keep the 0. So 20 times 7 is 140. Now, just like yesterday, we're going to check. We're checking when the numbers are easy, so that whenever I turn them into decimals, fractions, negative decimals, and fractions, you are still using that same strategy of checking that you practiced when it was easy. So it was x over 7 is equal to 20. You write the original problem to check. If I said x was 140, then I put 140 divided by 7 is equal to 20. 7 will go into 14 twice, keep the 0. 20 is equal to 20, so I know that is the solution. Now, since I know it is the solution, I can circle it as my answer. That was a division problem with equations. We were undoing it with multiplication. This one is a multiplication problem. Example 2. If I had 240 and that was equal to 4z. Again, I have an equal sign. I know that it's an equation. This is the center of the balance. To keep it balanced, what I do to one side, I have to do to the other. The only difference now is the variable is on the the right and not the left. You're still going to do the very same thing that you would have done if it were on the right. Some of you saw that yesterday on your practice where they just flipped it over. When you were adding and subtracting, the variable was on the right instead of the left. It's the very same thing. So, what's been done to z? I'm asking that same question at the beginning every time. Z has been multiplied by 4. What's the opposite of multiply? Divide. So I'm going to divide by 4. I'm going to divide by 4. When you do that, 4 divided by 4 reduces down to 1z. Four will go into 24 6 times, keep the 0. So we're saying that z is equal to 60. We're fixing to check it. So we're going to write our original problem. 240 was equal to 4z. Hayden? So 240 should equal to 4 times 60, which is plugging what we say z is into z. So 240 is equal to 4 times 6 is 24, keep the 0. 240 is equal to 240, so now I know that 60 is the solution. Example 3. Thirteen is equal to a divided by 5. It's an equation. Here is my balance. What has been done to a? It has been divided by 5. What's the opposite of divide? So I'm multiplying by 5. I'm multiplying by 5. Both sides. This reduces down to 1a. 13 times 5 is 65. I'm going to check it. 13 is equal to a divided by 5. If I said that a was 65, that's 65 divided by 5. 5 will go into 65 13 times. 13 is equal to 13, so I know that 65 is my solution. Now, for example 4, I'm going to pass out your worksheet to you first because there are a couple of fraction problems on your worksheet, and we're going to do one of those fraction problems as an example so that once you get to those problems, you have an example to go by, and hopefully you won't have as many questions if we've already worked one out, and you have an example to see. go back, which would say Math 6 homework 5.4. And look at the second column, the second one down. It says 1/3 n is equal to 13. One-third n is equal to 13. Now again, this is my balance. I'm again going to say what has been done to n. N has been multiplied by 1/3. What's the opposite of multiply? Divide by 1/3 divided by 1/3. That cancels and leaves n by itself. Now, about 3 weeks ago, we reviewed how to divide fractions. You have to have fractions. That meant you put a 1 under the whole number. And in your notebook, you still have notes on your rules for dividing fractions. That said, copy the first one, change divide to multiply, and flip the second fraction. Once you do that, it's multiplication. You multiply across top and bottom. 13 times 3 is 39. 1 times 1 is 1. And 39 over 1 is 39. So we're saying that n is equal to 39. So if we're going to check it, it's 1/3 of 39 is equal to 13. Again, we have fractions. We know we've got to have both of them as fractions, so we put a 1 under the 39. 1 times 39 is 39. 1 times 3 is 3. 3 will go into 3 one time. 3 will go into 9 3 times. So 13 is equal to 13. And I know that 39 is the solution. So still, even though there's some fractions in here, you know how to work with fractions. Fractions were 5th and 6th grade. By the time you get here, you're supposed to be proficiently working with all operations with fractions. So this is just throwing some fractions into single step equations. Any questions about that? Okay, don't forget, especially those of you who are in Avid, bring your problems out. That way, when you have your problems, when you're going over your notes tonight, you're able to cover up what we did in class, and over here on the paper that you used to cover, you're working out these problems. As you work them out on your own, you're pulling them down to see if you got the problem correct. If you did, and you keep going and you're still getting them all correct, then there's no need to spend extra time on it if you know how to do it. It's also how you know where to spend your time studying when it comes time for an assessment. Now, speaking of assessment, we have combined like terms, we have used the distributive property, we have put both of those together where we had to distribute and then combine, and now we have solved single step equations with addition, subtraction, multiplication, and division. So that means you need to be prepared for an assessment pretty soon, and I mean like within the next couple of days. We need to bring all that back together for a quiz so that now we don't have so much information showing up on an assessment. So that's where I'm going to stop with the assessment material for the next test you're going to have. Combining like terms, distributive property, putting both of those together, and then one-step equations. And it's just going to be one-step equations with positive whole numbers, and then we can put a few one-steps on to the assessment for two steps where we're using fractions, decimals, and negatives. Any questions? Okay, you may begin working on your practice. I'm leaving some of the examples up. If you need assistance, raise your hand. I'll come to you.